Yo, what's up guys, and this is my Minecraft computer. I've showed it many times before, and over the past few weeks I have been talking about all it can do, mostly the operating system. My next CPU should be done in maybe 2 or 3 weeks. I'll make a video about it then, but for now this is my current computer. Now today, instead of talking about the hardware, the actual computer, I want to talk about the software, which is in this case the operating system, and what I want in my next one. What do I want to add? What do I want to get rid of? What things do I want to make exactly the same? So in this video, that's what we're going to be exploring. So let's go. So let's talk about my old operating system. So what did my old operating system do, or the one in my last computer? Well, the first thing is data. I could give it information like numbers, values, and store it into a register. And then I could manipulate these registers using math. I could calculate with these numbers. So I guess we'll say data and calculating. Then there were files. Now, there were a few extra commands that were like exit to leave the program or output to output data in one of the registers, but I'm not going to write that. I'm just writing down the major concepts of this operating system. So I could give it data, it could move that data around, could calculate with that data, so I could add or subtract it, and then I could have files, so I could open files, I could write to files, I could save files. Now, as I've made it known, there were several limitations to my computer, namely the amount of memory. There wasn't enough memory for both my program memory for instructions and my RAM for files. If you guys haven't seen my last video, I would suggest checking that out. It talked about the new additions to my CPU and kind of my thought process when making this new CPU and the machine code. So we have all of these old concepts of this data manipulation, calculating, and files. Now, what do I want in my new operating system? Well, let's start with the easiest thing, files. I want files in my next operating system. It's going to be very similar to logic. I'm just going to have 4 instead of 3. Now, that's simple. It's going to be basically the same code. There's nothing really new here. But what else do I want? In this operating system, I also want to manipulate data. Now, I might not do it directly from the terminal this time, but through an app. So I can open a application or program within this operating system, and then I can run with data. So then like I was talking about in my last video, I have 192 free bytes of RAM for any of the other programs. So I can store a lot more data. I have a lot more free space for data. So I think that I can store data, but through some form of applications. This can be kind of special. Calculations, again, I do want to be able to calculate values. But again, instead of using the terminal, I can use some sort of application or extra program. So if you've noticed so far, these operating systems are looking very, very similar. Fundamentally, they really are the same, but in my new one, there's going to be a lot more accessibilities, a lot more functions, a lot more customization. And of course, I want other applications, so possibly a game or something else fun that I can code into this. But right now, I think we should focus on the big 3 right here. So now that I've talked about kind of what I want in my new operating system, let's talk about how I can actually do this. Now, the first thing that I want to talk about, probably the simplest here, are files. Now, this is going to be basically as simple as copy and pasting the code from my old operating system to my new operating system. I'm just going to basically take the file code, modify it to my new machine code, to my new assembly code, and just stick it in the operating system. Now, there is one thing that will actually make this file system better, and that is how my RAM is structured. Now, my RAM is 9, technically 10 bits, and it's broken up into 2 parts. The first top 4 bits, or top 3 bits, however you want to look at it, are for the file. So it's which file you're accessing. And then the bottom 6 bits are for that position in the file. So how my last operating system worked with the files is that I would have to keep a counter for the RAM. So I would give it the number of, like, which file number, so file 1, file 2, file 3. It would convert that to the first RAM cell, the first byte of that file, and then start pulling out bytes, loading it to the correct position on the screen, and then incrementing both the file position and the screen position. And it will do this 64 times until the screen is completely full. Now what I can do is I can decode the file, so F1, F2, F3, or if I want to give it names, and it will put that to the top 4 bits, or top 3 bits, and leave that there. It won't mess with it. And then I can have the same counter for both the file, because the bottom 6 bits of the file co-align with the 6 bits for the screen. So I only need to keep track of a single counter. And so by only keeping track of a single counter for both the file and the screen, this will basically have the amount of time it takes for me to load a file to the screen. So it is going to be much faster, much faster. So the file is going to be fairly simple. Just I might have to recode some things logically so that it's a little better for this format, but it's probably going to be the simplest thing to code here. Then my data. So last time, my last operating system, I just wrote from the terminal. So I told it to move data or to load data, anything like that. I want to have an application where I can load data, move data, and output data. Now, why is this different? Now, I do plan to have a lot more accessibilities with this data. So I do want to kind of reserve a section of my code for me to expand. So that's kind of why I want to break it off into an app. It's still going to have very similar functionalities, but instead of having 8 memory cells, because my RAM's a lot larger, I can afford a lot more. I have around 64 bytes for my operating system in general, just for general operating system stuff, which I'm definitely not going to use all 64. And then I have 192 bytes of free space, so I can afford a lot of data. Now, right now, I just want to have maybe 32 bytes to 64 bytes of RAM. So then I can access this with a 2-bit hexadecimal number, and I can use the same code that I did for my load function. With the load function, I would give it a register and a hexadecimal number. It would decode the hexadecimal number into a binary number and then load it to that register. And so I can kind of do the same concept here, where I decode the memory cell and then modify it so that it goes to the correct spot in RAM, and I can access that register. Then my calculator, which I think might be one of the most complicated things in this program, because it's going to be much better than my previous calculator. And so first things first, it's going to be able to access any of the data that I have created in my data app. Because what's kind of the point of my calculator if there's no data for it to calculate? So I want to be able to access any of these memory cells and calculate with it. Now, the thing I didn't like about my last calculator is that first of all, it could only calculate with registers. And so if I wanted to add 5 and 2, whatever, I would have to store the 5 to register, 3, and then store the 2 to register 1. And so I do register 3 plus register 1, and it would automatically store the result to register 3, the very first one I put in. Then if I wanted to output it, I would have to actually output that register 3, and so there's just a whole bunch of problems there. So like I said, first of all, it can't use actual numbers, it can only use data cells. And then second of all, it doesn't output the answer right away. I have to manually output the answer. And then third is that it automatically stores the result to some register. If I only wanted to see the sum of a number and not actually store any other numbers, just leave it as it is, I have to do a lot more maneuvering with my data. So I think one solution is pretty simple. Use numbers. So I want to be able to use a combination of data and numbers. So I want to have, 2 data cells or 2 numbers or a data cell and a number. So I want to be able to combine them. Now, the issue is the number is going to be a hexadecimal, and the data, the address of the data is going to be hexadecimal. How are we going to differentiate between the data and the number? Well, I suggest using some sort of symbol. So maybe for my data, I can do a percent sign and then put my hexadecimal number, maybe like 1E, and then that would see, oh, this must be a data cell. So then it would do the appropriate actions with it and access that data cell. And if I was doing a number, maybe I want to use a dollar sign, so something like this, and then I can put in my number, so maybe B1, and it sees that and says, oh, that's a hexadecimal number, so I don't want to put that in RAM, I want to hold on to that and compute it. Then I want to output the number right away. So first thing after I calculate it, it will output the result. Because most of the time I think I just want to see the result. I don't actually want to store it to data. And then it will give me the option to store the value back into the RAM, back into the registers. And so I can of course just say no and exit out of that, or exit out of that calculation. Or I could say yes and then pick any of the data registers and store it into that. So in that way, it's a lot more dynamic. The calculator can do a lot more things, so I can manipulate data a lot easier. So I hope that this kind of gave you guys a better idea of what I mean. So when I say I want files, I want some data, I want a calculator in my operating system, this is kind of what I mean. I hope this kind of gave you guys an expectation and an idea of what I'm going to be working on. And if you guys have any questions or if something isn't clear, feel free to comment. But I think that as the next few weeks progress, you'll see me working on my computer, working on my operating system, and a lot of these pieces will come together. And of course, at the very end, when I have all this working, I think it will definitely make a lot more sense. So feel free to comment if you guys have any questions about this. But that's all for now. Peace.